I'm just going to start off by saying to everybody, I don't imagine there's many people in this group who don't know who Tony is. I think he's probably most famous in our community for Starport, but obviously also games like Quest and Cyborg Warriors and Camelot. Tony's not just been an Acorn game developer, he's gone on to have an amazing career in games development and games design. Really looking forward to talking to him about that and his reflections as well on how games development has changed over the years. But that's probably enough from me. So what I'm going to do is just ask Tony, if you don't mind kicking off with, when did you first realize that you wanted to write games?
So I left school at 16, actually. I became not much to do with games, but I became a clockmaker, actually, ironically, and because there were no computers at school. And I didn't really enjoy being a clockmaker very much, actually. It was a bit of a dead-end career for me. But I did an A-level in computer science at the local technical college because my parents thought it'd be something I was interested in. I thought it'd be something interesting as well. And almost immediately, I found that I had an aptitude for making games. It was an old Commodore. Wasn't the PET? It was one of the other Commodores. I can't remember when it was. It was the old green screen monitor mounted, in a single plastic housing. And I started writing a sort of what was basically a kind of Pac-Man type game where this creature raced through a maze to try and find you. It's all written in BASIC. And I remember the lecturer being very, very impressed that I was able to do that, because I'd only been doing this course for a few months really by the time I was doing that sort of stuff. So I just knew how to make games pretty much immediately.
Hi, my name's Tony Oakden. I'm going to give a quick review of how I got into computer games. So I started making games back in the 80s, and it's kind of an interesting history as to how I got into it. I think people have a number of reasons for getting into games. Mine was kind of partly because I just liked playing computer games, but also because I found I had a natural aptitude for programming. So I left school at 16. When I was at school, there were no computers at school. I was one of the first people in my year actually to have a calculator. I had the old Sinclair Scientific calculator, which was a real novelty at the time. But I left school at 16. There were no computers at school, and I got a job as a clockmaker. And making clocks is an interesting career choice, but there are some commonalities between clockmaking and programming. And a lot of the work that I was doing was restoring antique clocks, and that involved looking at an existing clock, trying to work out what parts were missing, doing required calculations to find the missing parts, then fabricating those missing parts, and structuring my time to allow me to do all that work within a profitable amount of time. That involves quite a lot of problem decomposition, which is not that dissimilar to what you do in your programming. Actually, in programming you tend to get a high-level task, and you have to work out how you're going to decompose that into smaller tasks. And so I found that once I got into programming, those skills that I developed as a clockmaker strangely came into play, and I was able to reapply that, I guess, general project management skill to making games. So basically, I did some. I went to night school in the UK at the local technical college, and I did an A-level in computer programming, and actually computer science actually. And that was my first introduction really to computing. About that same time I bought a Sinclair ZX81, so about 81, 82, yeah. And I got the 16K RAM pack for it eventually. And I used that as part of my project for my A-levels. But while I was doing the A-level, I was introduced to programming, because obviously that was part of the course, and I'd never touched a computer before this, and it was extremely exciting to go into this room with all these computers in it. And the computers we used were all Commodores. I don't think it was actually the Commodore PET, but it was one of the very similar computers to a Commodore PET. This big, moulded plastic, single-piece computer with a keyboard moulded into it, and a green screen monitor at the back, and the monitor could only display characters, it couldn't display any graphics as such. And we were learning how to basically create for loops and if statements, and how to store data in arrays. Everything was in BASIC, and I started making a game because that was what I was interested in. So I made a very simple maze-based game which kind of was inspired by Pac-Man, looked more like Pac-Man, didn't look anything like Pac-Man, but had the same sort of attributes. You race a character around the maze using the keyboard, and you pick up power pills and enemies chase you. And it worked pretty well actually, and it was quite fun to play, and I remember the teacher being very impressed I was able to do that so quickly, and he was trying to help me improve my code. And I mean, I did pretty well at the A level. I think I got a B or maybe even an A, I can't remember. And I also did some programming on the ZX81 at home. I had a quick go at writing sort of a basic Pac-Man style, Space Invader style game. And I did a few typing programs as well. So eventually I sort of got to the end of that particular part of, I got as far as I could do with that stuff. I started looking for jobs in the Burton-on-Trent area, which is where I lived at the time. And there really wasn't a lot for IT at that time, certainly not people like me who were, I should say, somewhat lacking in communication skills, but technically quite good. So I was unable to get a job. And one day I was walking down the high street in Burton-on-Trent, and the only computer I had at this point was the ZX81, and I saw an advert for an Acorn Electron, and it was something like half price. It was a handwritten advert. I remember it was on a piece of cardboard at the front of the shop, just saying Acorn Electron, complete with 5 games. I can't remember how much it was. It was something like half the price it should have been. And I looked at it and I thought, well, that looks actually quite a good computer. And I went in and I had a go on this. It wasn't plugged in, but I had to go typing on it. And the keyboard felt really solid, and it just felt like a really solid little computer compared to what I was used to with the ZX81, which is a terrible computer to work with, really. And I thought, well, that's quite good. It's got 32K RAM. It does quite nice graphics displays, and it's got 5 games or something. I could have some fun with this. So I had a bit of spare money on my credit card, so I bought the Acorn Electron and got home. And I remember I started programming it in Visual Basic. It had BASIC built into it, so I had to do some basic programming. I didn't really look at any of the games at first. I just opened them up and tried loading them, and they didn't really impress me. The Starship Command I thought was quite good. I could appreciate them for technical aspect. And Starship Command I thought was quite interesting. Pac-Man was with it, and I played Pac-Man for a bit. Can't remember what the other games were. I know Starship Command was one of them. That was one of the better ones. Pac-Man was pretty good. The implementation of Pac-Man as well was good. Can't remember the other ones. What I do remember there was a text adventure, and I think it was this text adventure. This is Sphinx Adventure, which I think was the one that came with the pack of 5 games. And I didn't really play it very much, but then my mate came around that night and he loaded up the games because he wanted to see what they did, and he was playing this text adventure. Hey, this is pretty cool. And he looked at this, and I looked at it and I thought, hey, that does look pretty cool. And I started playing it, and after he'd gone, I continued playing it, and I played it for about 3 or 4 hours. And I remember just being absolutely enthralled with this idea of being able to walk around a world inside the computer. And even though it was just text, it just completely grabbed me. And even though, so graphically it's just text. You're just basically north, south, east, and west, and take bottle and stuff to do this, to interact with the world. But it was still, for me, much more interesting than the arcade games. And eventually I played it all the way through and finished it. And I remember there's one bit in it where, and I tell my students this story now, where you go down into a castle. And I remember walking down the steps of this dungeon. I can see it in my mind's eye, walking down these steps, and the light from the torches flickering on the wall, and the smell of the damp moss on the walls, and my footsteps echoing through this room. And there was a coffin in the corner of the room. I remember going up to the coffin and opening it and driving a stake into this vampire's heart, and being absolutely terrified that this vampire was going to wake up and kill me. And yet this was a text adventure which I played about 30 years ago. And since then I played a lot of games, played an awful lot of games since then. And none of them have had that same effect on me, really. And I guess to a certain extent, one of the reasons I don't play as many games now is because they just don't sort of, elicit that same sort of response. I think games are very much a thing of they're very much context-based. The game that affects you most is very much to do with the context and where you are at that particular point in your life, etc. Anyway, shortly after that, there was a local computer club which I started going to, kind of like one of these LAN parties without the LAN. We just used to go around and play computer, looking at each other's computers and watching what they were playing. And these kids had Citadel, and I hadn't really looked at any of Superior's games to buy them. And they were playing Citadel, and I was watching them play that, and I realised that it was it was the same as a text adventure, but with graphics. And it just suddenly struck me that that's an amazing idea. Why have I not thought of this before? So I bought the game from Super. I remember it was $9.99, which was a lot of money in those days for a computer game. And this game came, and I loaded it up, and I played it totally compulsively for about a week until I cracked it all and finished it and solved all the puzzles in it. And I absolutely love Citadel. I mean, I think it's a great example of a game of its time. These arcade adventures. This idea of being able to go from screen to screen and collect objects and move the objects between the screens, I just thought was brilliant. And I guess I immediately saw in my mind's eye how to actually do this and how to make a game that used those sort of systems. And I could see the game loop in my mind's eye, and I could see how all the systems worked, and I knew that I could code it. I thought I could make a game like this. So I set about making Citadel. So this Citadel's on the screen here. This is the Electron version, because it's got all this garbage at the top and bottom of the screen, which I think is basically because it's running in mode 2, I think. And mode 2 takes 16K for the display, or 20K for the display file actually. And clearly, that's not enough. It only leaves about 12K for the code and all the graphics. So what we used to do is to steal part of the display file. And on the BBC, you can cut that down because the BBC has a complicated graphics processing chip, programmable graphics chip, which you can change the size of the display and so forth. But on the Electron, it's all done using the ULA. And the ULA is limited to just 5 modes, so you can't do that, which is why the bands on it, the garbage bands at the top and bottom of the screen. But it didn't bother me because I didn't notice them when I was playing the game. So this is Quest, which was my answer to Citadel, and I started making Quest in BASIC. So I used the programmable characters. So the BBC on the Electron has, I think it's about 64 programmable characters, maybe 32 programmable characters, I can't remember. But they're monochrome, and you basically can program the individual bits of the character using hexadecimal. And I started making this game in monochrome using the programmable characters. And my idea basically was to make a basic version of a basic game and then persuade one of the magazines to publish it as a type-in listing. So it was all basic and it was all designed to be typed in. And I designed the characters on graph paper and then converted them to hexadecimal. And I got quite a long way into it before I realised that it was just far too big to be a programmable listing. It was already 1,000, I can't remember how many lines of code, certainly hundreds of lines of code. Clearly no one's ever going to type it in, it was nowhere near finished. So I thought, well, I'm going to have to do something else with this. And I thought, I wonder if I could convert it into full colour and actually do it as a proper arcade game. So I then started converting it into colour by gradually rewriting chunks of the BASIC as assembly language, 6502 assembly language. And I did a little bit of assembly language. I did a course at the Technical College in 6800 assembly language. And I'd done enough assembly language to know that I could do it, and I knew. That was very easy to me as well. As assembly language programming, it was very logical, and I knew exactly. I could see very clearly how to do it. When I came to do 6502 assembly language, I remember I was quite surprised that 6502 didn't have exactly the same instruction set as the 6800. But then I started to realise that all these CPUs are different. And I got the advanced user guide for the advanced programming guide for the Acorn Electron. Might have been called the Advanced User Guide, which is mostly a description of how the assembly language worked and how the Electron operating system worked, with a few tips. And that really helped. It's a really good book. There's another one for the BBC as well, which also really helped for the BBC machines. And I gradually converted all my code into assembly language and converted it all into colour. It was fairly tricky, but it didn't take too long. And then I was sort of committed to doing it in assembly language. And along the way, I had to develop some tools. So back then, there were no tools for game development. These days, of course, we'd use some sort of commercial or free editor to do the sprites, but I had to write my own editor. On the left here, this is the editor that I created for editing my sprites, and this was an offline tool. I think it might have been loaded at the same time into Cyber's RAM, once I got Cyber's RAM. But essentially, I'd load this tool up, and then I would load the characters up off tape, and then I would edit them, and then I would save the characters back, and then load up the game, and then load the characters off tape, and then build it into a single sort of data block. But the game would be stored in a single data block, and it was fairly basic. I mean, I didn't have a mouse, so I used the cursor key to move around the grid of colours and select what colour I wanted to do, and it was pretty basic. But actually, it was a lot easier than designing on using a graph paper and hexadecimal, having to work the numbers up by hand. So that was a pretty big innovation for me. And on the right is the level editor. So the level editor was actually, I did that fairly quickly because I think because I'd worked as a project manager, I worked in plot making. I recognised how important it was to have a fast production pipeline, because you don't want to be messing about having to, do extra work all the time. So I realised that, I think this is quite insightful on me actually, was that having the tools built into the game was a huge advantage. If I could just pause the game and edit the levels as I was going along, that would allow me to have a much cleaner production pipeline. I'd be able to sort of stop the game, or pause the game, make a change, and then continue playing it to see how it played. And that was I think that was a really important thing that I did, because it allowed me to have a very easy development path. Iterative. It made iteration very, very easy and quick. And that's one of the things that we really focus on these days in game development. We really want to have really fast iteration, because you don't want to have to save a game, load the tool, edit the level, then save the level out, and then reload it into the game, and then load your progress. That makes the whole process horrible. So wherever possible, we have the tools integrated into the game. So this tool, it's a fairly lightweight tool, because obviously you could have a big tool, but it was enough to allow me to edit the levels and then continue to play, which is extremely useful actually. And I could also place objects in the levels. And gradually what happened was, it kind of interesting. I'd work on the game a bit, and I play the game a bit, and then I'd think of something that I wanted to change, so I'd change it using the level editor. And then I'd realise that I couldn't do the thing I wanted to do with the level editor. So I'd go into the level editor code and change that a little bit to add that function that I wanted to have. Then I'd go back to the game and I'd play the game, and then I'd realise that now that I'd done this thing with the level editor, it opened up the opportunity to do some additional gameplay. And then I'd have to go into the gameplay code and tweak the gameplay code. And then I'd go back to the game and I'd continue playing the game. And so that was kind of like my development process. It wasn't like I designed the game and then wrote the code, and then designed the game, made the tools, wrote the game, and then shipped it. It was, a little bit of each all the time. Every night there would be some work on the tools, some work on the game, some work on the data, some work on the level design. And that was the way it went right to the very end, when I was iterated all the way through. And I think that's one of the things that is lost now in game development. It's very unusual to find that sort of very tight coupling between those different phases. It tends to be much more about, we spend some time making levels, and then we spend some time, so somebody's making the levels, I should say, and somebody's making the artwork, and somebody's doing the coding, and these people, they get together and talk in meetings, but it's very rare that there's an actual crossover between those disciplines. And I really, really miss that. And I think that's one of the reasons why the games that were made back in the 80s were so tight and did so much with the amount of memory they had. It was because it's extremely tight, I guess, very cohesive game design, because one person was doing everything, or the same people were doing everything. And it meant that everyone knew exactly what was going on. And you couldn't do that these days, of course, because these development environments today are so huge and so complicated that there's no way that I could know how everything works. But in those days you could.
And this is basically what your development hardware would have looked like, right?
Yeah, so on the left is what I started with. I started with a basic Acorn Electron with a tape drive and a black and white TV. I did a lot of the early development. Probably the first 4 or 5 months was spent working that way. So it's just at the beginning of the night, I'd load the stuff up from the tape, and I loaded it into memory, and then I'd basically work on it in memory. I can't remember exactly how the process worked. I must have had some way of, I guess I think all my code was basically basic, and the assembler was built into it. You used a for loop to basically do the 2 passes of the assembler.
Yeah.
And then at the end of each at night, I would save it back to tape. And I got into the habit of saving fairly regularly to tape, because if I accidentally switched the Electron off or something, then I would lose all my work, obviously, because it's just memory. And if it didn't save properly, then so the tape got corrupted, it wouldn't load again. That would be extremely sad. So I had hundreds of tapes, which I was constantly. I got to the point where I was terrified to save over anything, just in case I had to go back to it.
Yeah, I can imagine.
And then I can't remember. I think maybe about 3 months in, I bought a +1. So again, I saw one. It was massively reduced again in the Acorn user magazine. And the reason I wanted a +1 was because I remember there was a sideways RAM pack, which was made by, I can't remember who the manufacturer was, but basically it was like a cartridge that's plugged into the +1, which gave you an extra 32K of RAM, I think. And it was paged in, I can't remember how the paging system worked, but basically, so I think the bottom 32K of the machine's memory was ROM, wasn't it? The top 32K was RAM, something like that. And it paged the RAM in, so you could have multiple banks of RAM. And of course, that allowed me, using a bit of clever code, to have a lot more source code loaded at one time. So I didn't have to have the source code and the actual object code in memory at once. And also I could stick the operating system for the disk drive in there as well. So when I got the +3 disk drive, because the +3 disk drive was actually pretty intense, hungry in terms of how much memory it took. I think it took another like 4 or 5K of memory for its OS. But these same people who made the sideways RAM, they did their own version of the DFS, which ran in sideways RAM, which meant that I could keep a lot of memory free to the disk drive was running on sideways RAM. It's a clever system, actually. And then once I got the 3.5-inch drive, that kind of revolutionized my whole process, because then I could load the whole thing up really quickly, and it opened the door to having tools on the 3.5-inch stored on a separate memory, and just closing the game down and opening up a tool was no longer like a 15 minutes waiting for tape to load. It was almost instantaneous. So it was great, yeah.
And I appreciate it's a fairly long time ago now, but hearing you talk about the architecture of the systems, I mean, do you still have some like memory addresses and things that are just ingrained in your head? And
yeah, I remember E00 is where memory started on the Electron. That was with the that standard memory. That's where your memory started. The operating system went right up to E00. The first page of memory is reserved for the 6502 has a special set of instructions that only work with 0 page, e.g. addresses going from 0 up to hexadecimal FF. There's a lot of instructions in the 6502 only work with those. And then the next page, 100 up to 200, 1FF, is the stack. So the stack sits there. And then I can't remember what comes after that. I think the printer buffer comes in some soon time after that. And there's a keyboard buffer which also sits in there. But yeah, I mean, I knew where all this stuff was at the time. I remember there's a memory address, FFOD, which I think when the machine crashed, if you wrote to that address, you could, because it would lock up. That's right, the machine would lock up and you couldn't get it back. But if you wrote, I think if you wrote 0 into that address, then for some magical reason, everything restored back, and you could get your code back. Because the code would disappear and it was gone. And then someone said, "Oh, you just write 0 into this memory location," and the code comes back, and it did. It was brilliant.
Yeah,
it's amazing. But yeah, I still remember those sort of things. I remember that there's some instructions on the 6502. There's an instruction called a post extended indexed addressing, which only works with the Y register, which is the one which you use, kind of the equivalent of a basic array statement. So yeah, it's still floating around inside my mind, completely useless information, which I don't suppose will ever get used again. But it's still there. Yeah.
I think it's because of what you were saying before, isn't it? That you essentially had to understand the whole system to be able to, almost like you have the architecture in your head. It's amazing.
Well, you also eat, breathing, and sleeping this stuff. I mean, I used to go to work. Because I was still doing my job as a clockmaker, and I'd come home at about 5:30 at night, and I'd just sit down in front of the computer and start coding. And I probably coded until about 8 o'clock when I got hungry. And then I go and, I don't know, cook something in the microwave, beans or something. Then I sit down again and carry on working till midnight. And then if I was on a bit of a roll, I might carry on working till 1 or 2 o'clock in the morning. If things weren't going so well, I might stop and go to bed at that point. And often I'd wake up about 7 o'clock, and whatever it was I've been struggling with the night before would have clicked in my mind, and I'd start coding again before I went to work. And I did that pretty much 7 days a week. On weekends, of course, I just coded. I did nothing but code because I didn't have to go to work. So yeah, you're just living, eating, and breathing this stuff for months and months. Yeah.
Wow.
So yeah, it's.
And I think you've included this. This is a map of the.
So this is like a quest. There's two reasons I wanted to show. One is just to highlight how slightly hodgepodge it is. I mean, I did have some ideas. You can see in the middle there's a big area of water. I wanted to have this idea of a water tank in the middle. But really, it's more of a maze than it is a cohesive sort of game world. There's not a lot of cohesiveness about it. It's just a series of random encounters almost stuck together in a maze. But that also, that's interesting because that map, after I shipped Quest and Superior, so they wanted to publish it and they agreed to publishing, I wanted to sort of get involved in the whole marketing, PR side of things. So I suggested to Superior that I made a map of the game. And of course, in those days we didn't have. It was quite difficult to make it electronically. There's no tools that would allow it to make a high resolution image of the map. So I got in touch with a local company, local to where I lived, who were making inkjet printers, and I asked them if they'd lend me an inkjet printer in return for free publicity. So they lent me this 3D printer, which is a thermal inkjet. Actually, no, it's a thermal color printer. And I wrote this code to screen dump all the screens. Then I wrote code to cycle through the screens, printing them out one by one. And remember, it printed them out in a long vertical line, so it printed out a vertical column of screens.
Yeah.
And then I cut them and then glued it all back together with sellotape. So that's a copy of the original map that I made, and I sent it to Electron User. I think and Electron User published it. Yeah. They just published it in the magazine, so it's kind of cool to do that.
Yeah, absolutely. I mean, I think so you're doing it a disservice when you say it's hodgepodge. I mean, there's a lot, like there's so much kind of complexity to the overall design of the game.
It is complicated. It's complicated. Yeah. But you can see how I wanted to get this feeling of forcing the player to. I really like this thing in games where you show the player something which they know they've got to get, but you don't actually provide them with at that point with the mechanism to get to it. I think that's a really powerful thing. You see it in a lot of games. It's used in, games like Zelda makes extensive use of this sort of mechanism where you'll see something on the other side of a wall which you know you need, but you don't know how to get it. And that's a really good technique because it's that carrot and stick approach where you're providing the player with a carrot. You're saying this is what you've got to get, but you also provide them with a stick when you're beating them if they do something wrong, And it's just a really good way of providing that momentum to keep people going. So I was keen to do that. I think it was quite a good. So stuff I'm very proud of, But it's a fairly good variety of puzzles in there.
Indeed. Yeah. So sorry, I realise I asked you this question a bit prematurely before, but after Quest, you obviously were keen to work on a new game. So can you tell us a bit about how that evolved?
So I realized I couldn't get much more into the machine's memory than I already had. So what I suggested to Superior was we made a game which was set over maybe 4 different worlds, and each world was loaded separately from a tape drive. And the idea was I'd make a single sort of adventure game engine, which would then load the data for each world. And when you completed that world, it would load the data for the next world. I think actually Ricochet probably did the same thing. I never actually played Ricochet, but I know that was multiple loading thing. And I got all this working. I got it to work. So I got my core engine, and so the engine would load up the level layout and the tile designs and so forth. And then it also had some sections of code, which there'd be about, I think it's about half a K of code, which is unique to the world that it was loading, and it would kind of link that in as it loaded it. So I did 2 worlds. I did the Camelot world,
Mm.
and I did a science fiction world for Starport, and there was a 3rd world which I started, which I think was the jungle world. And at that point, Superior said, "Look, we don't want to do the entire game." The market was rapidly diminishing for BBC and Acorn Electron games, but they were keen on taking the Camelot game and just releasing it as a single standalone game on one of their Played Against Sam games. So they paid me a reasonable amount of money for it and just shipped that, and I was left with the engine and the game which was going to become Starport. And at the time, they didn't seem particularly interested in Starport, but later on they came back to me and said, "Look, would have prepared to finish that for, I think, whatever Played Against Sam game they were working on at the time." So. Yeah.
So was there ever an intention on your part for Camelot, Starport, and this 3rd jungle area to be one massive game, or was it?
Yeah, that was the intention.
That was the idea.
Yeah, that was the idea. It would be one giant game. I had this overarching idea of this guy who was traveling through time, solving like a detective traveling through time, but it never happened. And in the end, I just broke them out into separate games, and all that narrative was junked. And instead, I focused on them being comparatively simple. So it's just King Arthur and this lone spaceman in the space station.
And this is a map here for Camelot, isn't it?
Yeah, so this is and I include this basically because it shows obviously this is a much more cohesive design. It looks more like a castle than Questas, but also it's obviously very similar to the map that's in Citadel. If you've ever seen the maps of Citadel, the Citadel's got this big central area and then these areas branching off left and right of it. So you can see how heavily I was influenced by Citadel when I made this. I remember thinking it was kind of almost like a little tribute to Citadel. But I mean, it's quite a nice map, I think. I mean, they're quite nice. It's quite nice to see these maps actually when after you've worked on them and you see them all printed out like this. So whoever did this, I think they did a really good job of it. And obviously, I've broken out into 3 sections there. The top right-hand map up there is on the left of the castle, and the other one's on the right of it. So.
And did you? I mean, as you say, it's nice to see them blown up like this. So did you kind of hand draw them on paper as you were working through the game?
Yeah, I hand drew them on paper.
Yeah,
I had this huge picture on the wall, which I would. I think each individual screen was a separate small piece of paper, which I drew a grid on, so I could keep track of where everything was. Yeah, you basically had to do that, because otherwise I would never be able to see where everything was.
Yeah, yeah.
Because you see, yeah. Go on.
No, I was going to say there's only so much, I guess, you can keep in your head, right?
That's right. You've got to have some
paper.
sort of reference, because I'd forgotten where all the objects were and what opened which doors and how it all worked. You just can't remember it all.
Yeah. And then this is the Starport map, which is I love the design of this one.
Yeah, I think this is a much better design. This is really, this is the last adventure game I did. I think you can see the progression between these 3 games. How by the time I got to this one, I'd really thought about how I wanted to tell a story in the map and how the environment is, much more cohesive. There's a loading bay and there's a reactor and there's a escape ship at the top, and it's all it makes a lot more sense in terms of the layout of the map. So I was really pleased with this. I mean, now I would do more with it, because I'd probably have proper cruise quarters and Medibank and Medicare Centre and stuff. So, but it's still, I think it's pretty cool.
I think it's amazing.
It's pretty good for whatever it was, 16K RAM or whatever. It's pretty small.
No, it's really really impressive, and there's a lot to Starport as well. I mean, because you added in this really innovative idea of the spinning wheel puzzles to get through certain areas. How did that come about?
So I got a portable Amstrad computer, which somebody had sold me, because I was thinking about getting into database development, and so I got this PC, and there's Visual Basic came with it, and I wanted to do something with Visual Basic. I don't know where the idea of the wheel came from. I know I was trying to think of something in 2D which is similar to a Rubik's Cube, and I just came up with this idea of 4 interlocked wheels which you would turn. And again, it's a very holistic sort of process where you think of some code and you think of how you might use that in a actual puzzle, and then you make the puzzle and you think, if I change the code, it will allow me to do this. So the the puzzle works because the wheels are encoded into 4 arrays which sit on top of each other. So it's kind of really neat because the implementation is actually quite neat. It's not as complicated as you might think. And so it made it very easy actually to implement it in 6502 assembler. When I came to do the port, it was actually because it already works out in BASIC and it was more of a data-driven algorithm. It coded very easily into 6502 assembler. And so yeah, after I got it working on the PC, and I'd made Starport. I was thinking, well, maybe I could use this sub game in Starport. A friend of mine was working on a game for the BBC, which I can't remember what it was called, Joe something or other, which is a monochrome.
Is it Joe Blade? Is it?
Yeah, I think it was Joe Blade. Yeah, Blade. It was Joe Blade. Yeah, and I remember that had a mastermind type sub game in it where you had to defuse the bombs by working out what the code was. Do you remember that?
Yeah, I do.
Yeah, and I thought, oh, that's quite cool having this sub game system. So that's kind of where I came up with this idea of sub games. And I had these interlocked wheels, so I could do that. So combine the two. It actually works pretty well, I think. I think it is a pretty good, because it breaks the game up a little bit, provides you with this additional challenge.
Yeah.
And you can quit. You don't have to solve the puzzle. You can go into it, and you can quit at any time. But if you quit at any time, it's cost you some of your oxygen. You know, because it takes you while you're in the puzzle, it's taking oxygen. So it's got this sort of crystal maze type thing where you're locked in and you're trying to solve this puzzle, and you can quit at any time, but there's a cost to doing it. And if you don't quit and you don't, you get right to the end, then you die. So there's quite a big penalty for getting it wrong.
Yeah. But I mean, it's quite generous on your part as the game designer for it to at least give you the option to exit it, because a lot of games from this era were pretty brutal. It's like you either get it right or you just died.
Yeah, well, that's probably what I would have done earlier on actually, but I kind of learned to be a little bit gentler with people. But I was playing the other day, and I've hidden because you've got to get 5 medical crates, and one of them's completely hidden in the thing. And the only way you'd know it was there would be if you sort of thought about the map. Thought, well, why would I make you jump up onto this platform if there's no point unless there's something hidden here, and then you would check to see what was hidden there. So it's kind of it's a bit of a tricky puzzle to solve. I remember I actually did that did you play Camelot at all?
No, I haven't personally, no.
Yeah, Camelot's got this puzzle in it where because I did stars in the sky, and I realized I could make patterns out of the stars. So one of those patterns I made was the plow, and the plow, you know only about astronomy, but the top 2 stars of the plow point at the pole star. Do you know this?
I didn't know
this. Because if you need to navigate, you don't have a compass. Being able to find the pole star is really useful, because you know which way is north. Because it doesn't work at all in Australia, because none of these stars are visible in the southern hemisphere, but in the northern hemisphere, yeah. So I did this plow in the sky, and then it points to a star, and basically there's a clue in the map. It's set in the game somewhere. It says dig due north. So you've got to stand underneath the pole star. You dig straight down with your spade, and then you find a hidden passage. That's where,
nice.
Well, that's quite a cute puzzle, actually.
Yeah, definitely. And in terms of Starport as a game, I mean, it's big and it's complex. So you must have used some special tricks in the programming of it to achieve certain things. Yeah.
So if you just go back to the previous screen.
Yeah, sure.
Is it that one? The one before that.
This one.
Probably
here?
one before that. The one before that, actually. Yeah, this one. So. Now go back to the picture of the Starport. The next one after this.
Sorry, I think there's a bit of a lag. Is it this one?
Okay, yeah, that's one. Yeah. So I said before, on the Electron, you don't have a programmable video chip. You can't program the video chip. So that means you can only cut the screen down memory from the screen. It shows up as garbage at the top of the screen. So on the BBC, you can cut the screen down by reprogramming the CRT chip. So there is one way of doing it. The Electron has 2 interrupts. It has an interrupt which cuts in when the raster hits the top of the screen, which you can use to turn the screen black. But then there's another interrupt which kicks in 50th, 100th of a second later. Yeah, I can't remember what that one's called, which you can also trap, and then you can turn the colors back. And that's what Peter Scott used on a lot of his games. Thunderstruck and Spy Cat. All these games have this sort of quite narrow letterbox look to them, and that's because he's using those two interrupts to control the size of the screen. So he's got lots of garbage on the screen, but you can't see it because he's turned the colors black and then he's turned them back to the normal color again. But I wanted to make I didn't like that letterbox look. I wanted the screen to be more like a normal aspect ratio. It's a widescreen aspect ratio like this.
Yeah.
So in order to do that, I came up with a system whereby when the raster hits the top of the screen, I turn the colors black, and then I use the actual drawing of the sprite as a timing loop to control the next switch. So what happens is that the interrupt kicks in, turns the colors black, and then I start drawing one of the three sprites. There's always three sprites on the screen, the main character and two others. And then I draw that sprite in, and then after I finish drawing that sprite in, I turn the colors back to what they normally would be. What that means is I can control the size of the screen. I can hide all the garbage at the top of the screen, but also it guarantees that the sprites never flicker because it's drawing the sprites whilst the raster is on the top part of the screen where you can't see it because by definition it's black.
Yeah.
So it's quite a nice system actually. Of course, the problem is your timing of your sprites has to be exact because if the sprite is even slightly a fraction of a second different, then the screen flickers horribly because you've got this horrible flickering going on. So I had to, really be really careful with my sprite drawing routines that they were always exactly the same length to draw every single sprite, regardless of where they were on the screen. But once I got that working, I'd use that for both of these games. Yeah. So it's getting quite cocky at that point as to what. The other thing I did, I turned the whole game into mode 7 because mode 7 on the BBC on the Electron runs much faster.
Yeah.
So it does this weird set of switching, and it's pretty pleased with it really.
I think when we were chatting before as well, you mentioned there was something you did for the radiation suit in Starport as well.
Yeah, so that's sort of optimization you have to do. So these days, of course, we'd have a separate sprite for the radiation suit, but there was no way I could afford another sprite, and because you've got to have all the animations as well. So what I do when you pick up the animation, when you pick up the radiation suit, I've got a bit of code that goes through the main character's mask and turns it from every pixel it sees it's red, it turns it to yellow, and every pixel that yellows it turns it to red. So it flips them over. So it's this bit masking code that goes through the sprite, flicking all the colors over. So that literally it just goes through the original sprite and literally in main memory just changes it to be yellow. And then when you restart the game, of course, I then have to be really careful to remember to turn it back again. Otherwise, you start off the game with a yellow character because it would be yellow,
Yeah.
So that's the sort of thing we used to do. Self-modifying. I used self-modifying code as well. It wasn't just the data which changed. I think when the spaceship moves, I actually changed the level data so the spaceship moves, and there's bits of code that are rewritten for optimization purposes because it was easier to do that than it was to have duplicate the code. So
it's really impressive.
Dodgy tricks we play. Yeah, well, when you've only got a little bit of memory, you really learn to get the best from it. We wouldn't be doing those sort of things today because it would be just too that sort of very I guess dedicated code is just too difficult to maintain. So you've got a lot of it, then it becomes really difficult. But when you've only got 16K, you can sort of afford to be a bit creative.
I mean, I think that's in a way that almost sort of drives a certain level of innovation, doesn't it? You've only got that much resource. You're almost forced to be more creative with what you do.
Yeah, absolutely. Yeah, of course. Yeah. I really loved it. Yeah.
So in pretty much the games you'd produced up to this point had followed this puzzle style adventure game, but then your sort of last game in the Acorn world was Cyborg Warriors. So what was the thinking there? Was that you wanted to do something different?
I did want to do something different, and I was playing a game in the arcades called Sidearms, which I loved. I love Sidearms. I played it a lot. It's a really fast sideways scrolling game, and I just love the idea of these two dudes just flying over this barren landscape, shooting the crap out of stuff. There's no real logic to it. That was what I wanted to capture. I wanted it to be a two-player game, and I wanted it to scroll really fast sideways. So for this game, I did actually rely on the interrupts to cut the screen down to the normal sort of letterbox shape. Which works pretty well for sideways scroller because everything's coming from the side. So having a long, thin window of a game works. And technically, it's quite good because what I did, there's two main techniques you can use for drawing sprites. You can use exclusive drawing to draw the sprite in, and you basically your exclusive orbit on top of what's there. And that gives you this weird sort of semi-transparency look, which is the way that Citadel and Quest work. Then the next way of doing it is to draw the sprite in. As you draw it in, copy out the data that's underneath the sprite, then mask the sprite in, and then when you want to erase the sprite, you copy the data that you recopy the data that you copied out before back in over the display. So that allows you to redraw the sprites. But I figured that the third way would be to just redraw the entire backdrop. So I figured if I could do it fast enough, I could just blip the entire backdrop in, effectively erasing everything, and then I could redraw everything on top of it again. And I figured that that'd be much simpler to do because it would allow me to freedom to draw whatever I liked, and I wouldn't have to worry about having buffers to copy things off. But it would be, and it also allowed me to do a fully animated backdrop. And the other thing I wanted to do was this idea of what's called double buffering, which I hadn't done before. Double buffering is a technique where you're drawing to the screen whilst the video hardware is displaying another buffer. So when you finish drawing the screen, you flip the buffers over, so the thing that you were drawing to now becomes the image that gets sent to the the video monitor. And that's quite an advanced technique, which I don't think got used very much at all on the BBC. And I could get away with it here because this display was fairly small, and because my knowledge of the hardware was so good by this point, I was able to write the code to do it. And it worked really, really well, because it means you've got this full screen scrolling parallax screen, which doesn't flicker at all, and runs to really rock solid 25 frames a second on the BBC. On the Electron, I couldn't quite. So the image on the top right-hand corner there is the Electron one, and you can see it doesn't have the parallax scrolling landscape. It's just the whole thing is black, because I couldn't quite get the Electron to do all of that. I needed a more optimized routine. But on the BBC, the whole bottom scrolls quite impressively, actually. Yeah. And it's a pretty fast, smooth game. It just, it was really good. I was really pleased with it. I did actually get it running at 50 frames a second at one point.
Oh wow.
That was really. It was beautifully smooth. But unfortunately, by the time I started putting any sort of number of enemies into it, it started to stutter. So it's better to drop, stick it at 25. It's just a little bit. It's not quite as smooth at 25 frames a second, but it's still pretty damn good, really. So yeah. And then the movement pattern for the enemies, I spent quite a long time developing, various. My maths was getting a bit better by this point, so I was able to work out the maths to control these things. And
was it quite a different challenge writing a game like this then compared to the ones you'd done previously? Did it feel quite different?
Yeah, it was. It was really interesting, actually, and I really enjoyed it. And I learned a lot doing it. I remember one of the things that I was working with my friend Wayne quite a lot at this point. I was bouncing ideas off him, and I'd made the first level of the game. Spent quite a long time working on it. And I gave it to him to work on, and not to work on, to play. And he came back to me a bit later and said, "Yeah, it's technically really good, but it's way too hard. It's far too difficult. There's no way that anyone could ever play this." And I was like, "No, it's fine, honestly." He said, "Well, show me your play." So I played it, and I got through the first level, but I did lose a couple of lives. And he said, "Look, I want to see you play it without losing a life." And I played it, and I couldn't get through the first level without losing a life. And he said, "Look, obviously it's far too difficult." I had to admit that probably it was. So I moved half the enemies and made it a lot easier, and then let him have a look. And he said, "Yeah, it's much better, but it's still far too hard." And I said, "Look, I can easily play through it now without losing life." He said, "But you know how all the enemies are working and everything." So I dumbed it down again. I dumbed it down again. I dumbed it down again. Eventually, I think I got enough stuff from the first level to fill the first 3 levels, because it was so crammed. I crammed so much into the first 3 levels, that the first level. So I spread it all out, and that was 3 levels. And we sent it. And when the reviews came back from Acorn mags, the first thing they said was it was a great game, but a bit too hard. So even after doing all of that, it was still too hard.
Imagine if it had gone to market without any of those changes.
Yeah, it would have been a Gary Partis game, wouldn't it? Because Gary Partis' games were ridiculously hard, I remember. Yeah. Far too hard.
Yeah. And there's quite an amusing story you told me about how it actually came to be published, right?
Oh yeah, so that was right. Yeah, so this was right at the very end of the Acorn market, and I sent it to Superior. I actually sent it to Fourth Dimension as well. Actually, they were kind of interested, but they got their own first-person shooter. It was Nevrion, wasn't it, or something?
Oh yeah, Nevrion or Nevrion, yeah.
Yeah, something like that. Well, it was called Nevrion. So they weren't that interested in it. So I sent it to Superior, and they said, "Yeah, it's a bit too late now. We're not doing much more." And so I thought it would never see the light of day. And then I got a call from one of the Hanson brothers saying, yeah, we'd like to use Cyborg Warriors on the last played against Sam. We think it would make a lovely addition to the set. And I said, that's great. I said, to be honest with you, we completely forgotten we had it. And it was the tape was sitting in this guy's drawer, and his kids found it, and they just plug it into the computer, and they realized it was 2-player. There's 2 kids, so they got the joystick out, because you could play it on 2 players. There's a red and a blue character. The red character was controlled using the keyboard. The blue character was controlled using the joystick. And they were having an absolute blast playing this game, the 2 of them. They loved it. And this guy said, oh, wow, perhaps we should do something with this. So that's how it got released, because his kids really liked it. Otherwise, it would never have seen the light of day. It's
Wow.
sunk without trace.
Well,
Which would have been crime against nature.
absolutely.
I think they paid me like £400 for this. That's how much I made. It's for like, I don't know, 6 months development. It's terrible, really, when you think about it. But that was the nature of the industry. It's just the bottom really fell out of the Acorn market towards the end, and you can't give stuff away, unfortunately.
And was that how it worked then? You would just be paid a flat fee and no royalties?
No, it wasn't. No, for Quest and Camelot, I got royalty. Quest, I got quite a lot of royalties for Quest, and Camelot there was a one-off payment and then royalties if it did more than a certain amount.
Oh, okay.
But once we got onto Starport and Cyborg Warriors, it was a flat fee. It was just a one-off fee.
Yeah.
Because the market had pretty much gone by that point. Yeah.
You've got the 6502 chip
the
here.
veritable 6502, which is my favorite CPU. I don't know. Maybe it's a bad thing that I've got a favorite CPU. But the 6502 is definitely my favorite CPU. I worked on a lot of Z80 and 6800 and 68000, all the ARM machines and all the variety of the 68 X's. The PC, the 38 X's and Pentiums and stuff. And it's 6502 is by far the nicest CPU to program on. It's a really nice, well laid out instruction set, and makes a lot of sense, and it runs fast, and it's just nice to use. I really liked it, and I encourage people to have a look at it. Actually, it's an interesting historical CPU. It still gets used, I think, it's kind of funny, because when I went to at one point I was working in the slot machine industry in the UK, making fruit machines, software fruit machines, and one of the companies I worked for was still using the 6502 as the main processor, which drove the motherboard in their.
Oh wow.
That was mid 90s, late 90s actually. It's still 10 years after the BBC Acorn machines had stopped being produced. Very, very good processor. Yeah,
absolutely. I think you'll have a lot of people nodding along in the group here, agreeing with you.
Yeah, it's great.
So I'd be keen to hear about where life took you really after Cyborg Warriors and Acorn programming. What happened next for you, Tony?
So you may remember I did a fairly poor game for the Acorn Archimedes called The Exotic Adventures of Sylvia Lane. I don't know if everybody ever played that, which I think really demonstrates how poor my skills were as a graphics drawing graphics. So I didn't really have this. I think the main problem was, and I wasn't alone. There's a lot of people struggle with this as well. It's fine to make games on your own when you've only got 16K of RAM, because the graphics are by very definition very simple. But once you start trying to make things for Amigas and machines which have got a lot of memory, you really need to employ artists, because it needs people who actually know how to wrangle those pixels to make them look good. And I just didn't have the communication skills to do that. So I didn't have the skills required to create a team or work with other people. So I really struggled to make that transition into the next generation of hardware. And in the end, I went to university and did a degree in computer science, electronic engineering. I went to Keele University in Newcastle under Lyme, in the Midlands, Stoke-on-Trent. And whilst I was there, that's when I developed Exotic Adventures of Sylvia Lane, actually. So I did that. And afterwards, I was going to go into industry. I wasn't really intending to go back into computer game development, but I was persuaded to send my CVs off to various people. I actually got a job for a while working in the slot machine industry. That's when I worked in the slot machine industry. And after that, I got in touch with a recruitment agency to see if I could get back into the games industry. And they got me an interview with Reflections, who were the people who made the original version of Driver for the PlayStation 1, which is the game in the middle there, which was voted best PlayStation 1 game ever. I'm not quite sure that's true actually, but that's what they voted it. It was a very good game, Driver. And I went for the interview, and I was interviewed by these young guys who were, and I was already old for the games industry then. I was only in my 30s, but I was already old. They clearly were not that impressed with me. At least they asked me some questions, and afterwards they said, "Look, the CEO wants to speak to you." And so I went into the CEO's office to speak to him, and it was Martin Edmondson. Martin Edmondson was the guy who made Ravenskull.
Yeah.
His game Ravenskull shipped pretty much the same time as Quest, so he knew my games, and he'd seen my article in Electron News, and he knew me by reputation, and I knew him. So we had a long chat, and he offered me the job to work at Reflections as a programmer on the PlayStation version of Driver. So I went from making slot machines to a PlayStation programmer. And I really liked the PlayStation, actually. It was kind of cool. That was a pretty cool piece of hardware as well. The PlayStation picked it up pretty quickly. And Driver was enormously successful. We did some amazing stuff with Driver as well. Although Driver was a much bigger team. My job in Driver was really the sort of the icing on the cake. Things like weather effects, cool lighting effects, smoke effects, and various other things I did. The really cool stuff like the renderer and the physics engine were done by other programmers. So it was my first real experience of working in a much larger team. There's at least 8 programmers working on Driver, and a team of maybe 12 artists and a designer. Probably about 30 people altogether worked on Driver for about 2 years, probably. I worked on it for 18 months, but they already had a working prototype when I joined the team. So that was quite an experience.
Yeah.
I remember I was in Ireland on holiday with my wife when the game shipped, and we were in. What's your local game store? In Australia we have EB. You have something else in. I can't remember what it was. Anyway, at the time games were still sold at the high street in boxes. I mean, I imagine that. Imagine going into a shop and buying a game in a box. And actually, the game actually being in the box.
True.
Went to EB the other day, and they had what's the game? What's that tower game that came? It's the Cyberpunk. So Cyberpunk. And I picked up the box and looked at it, and it says on the back of the box, says this box does not contain the game. You have to download it. I was like, what's the point? What's the point of going and buying an empty box? Might as well buy it on Steam, download it.
Yeah.
What's going to happen if you've got a terrible old ADSL2 connection? Anyway, that's irrelevant. But anyway, so this game shipped, and then we were wandering around the island, and I was a bit drunk because I've been drinking a lot of Guinness. And we wandered into this shop, and the game was running on a monitor above for everybody to watch it. And there's loads of people standing around watching this game, pointing at it, saying how amazing it was. And it was a game that I'd worked on. It was an amazing experience, Yeah, it was staggering. So then I tried to play it, and I couldn't play it, of course, because I was drunk. It's very embarrassing. And then after that, I got promoted to lead programmer on Driver 2, which I'd worked on for a while. But then the opportunity came for me to emigrate to Australia and work with a team in Australia. And we worked on a game called Fallout Tactics, which is the game on the right there, which is a tactical combat game set in the Fallout universe. So Fallout 1 and 2 had come out. Fallout 1 and 2 were isometric RPG games. And we made a tactical combat game using the same combat system. And I came out originally as a senior programmer. By the time I got to Australia, the senior programmer had gone, and the lead programmer had gone, so I got promoted to lead programmer. And by the time the actual project kicked off, the producer had gone, so I got promoted to be producer. So I ended up running the team in Australia, which was terrifying for me because they're a very young team. But they were really, really good. They had really good artwork, and it was actually a really good team. So that was actually a pretty good project, actually, I thought, Fallout Tactics. We were published by Interplay in about 2002. And then I left Michael Fortin, which is the company I was working for then, and went to work at Irrational Games, also in Canberra. And we worked on a game called Tribes Vengeance, which was a first-person shooter set in the Tribes universe. I was producer on that for 5 years. Didn't do particularly well. It got very good reviews, but it didn't sell very well, unfortunately. But then Reflections used that money to kick off their great opus, BioShock. And I eventually ended up as a producer on the PC version of BioShock. So it's kind of interesting progression. I went from one-man teams to working on Driver, which was like a 30-man team. Fallout Tactics was probably like a 40 or 50-man team. BioShock, I had about 16 people working on the PC version in Canberra, but there were at least 50 people working on the 360 version in Boston, and we had a team working in China on art assets, probably about 20 people in China, and there was a QA team in Ireland who must have numbered at least 20 people.
Wow.
So there was a production team as well, and a marketing team, and all these different people. There's probably 200 people involved in it for quite a long time.
Wow.
So that's how these things change, and that's a small team now. If you look at something like Blizzard now making whatever they're making, and when they made Overwatch, I think Overwatch had hundreds of people working on it. Ubisoft have teams just dedicated to the animation system. They have a whole team whose job it is just to make the animation system for all of their games. So whenever you play Assassin's Creed or Tomb Raider or any of the games they make, it's the same animation system. So they have this incredibly elaborate motion capture studio and inverse kinematics system, which they can blend characters with real-time physics, and it's a really amazing system. And it's one team who does that, and they've got about 40 people on that team, and there's another team who do all their AI, another team is doing research in machine learning, another team is doing the rendering. So it's an enormously big endeavor, and the problem is that one person, of course, never gets to see anything like the whole project. You just see this tiny little bit of it, whereas at least if you're a producer, you get to see everything, even though you don't actually get to contribute to anything.
I was going to say, as being the producer on like a massive game like that with so many people working on it is probably the closest analog maybe to doing a game on your own in that overarching view, right? Yeah,
you get to see it all, and you get to contribute. You get to make suggestions to everything, but you don't get to actually do anything. You don't do any programming. You don't make any art. You don't make any design decisions. But you just get to, you're at the top of the ladder. It's one of those situations where if things go really well, you get to pass a lot of credit on to the team. When things go really badly, you take the blame. So you never really. It's a very hard job. You get paid well for it, but it's hard.
Yeah,
I was very lucky actually to work on a couple of really good projects. I mean, BioShock is a great project to have on my CV, really.
For sure, yeah.
And it was great to work with people like Ken Levine and Jonathan Che, who were just bona fide geniuses, really. Martin Edmondson was also a genius. He was a genius as well. And so they were great people to work with. It's one of the great things about working in the games industry. You work with great people, for the film industry.
And I think you said to me that you've also worked on what I would call quote unquote serious games as well, right?
Yeah, I've done some serious games. I worked for quite a while. I worked with a mining company in Australia called BHP Billiton, and they've got a big numerical simulation which they use to because they're shipping millions of tons of ore a year. When they dig it out of the Pilbara and they ship it by train to the coast in northwestern Australia. And it's almost like a production line. These massive great tankers come steaming into the harbour, and they load it up, and then these tankers go out again. And it's a day in, day night. They're shipping ore out to China, and they've got these huge stockpiles where they stockpile this ore, and it's like millions of tons of ore, and these huge machines which load and unload this stuff. These machines are as big as office blocks, and they're completely controlled by computer. Because I went up and had a look at it. So the whole system is incredibly complicated, and it obviously has to be highly optimized. So they run all these simulations to work out the best configuration of stockpiles and the best configuration of trains and stuff. So they've got this huge numerical simulation which is running all the time. But because it's just numbers, it's very difficult to visualize those numbers. The numbers get popped out in spreadsheets and graphs, which are really difficult to understand. So they employed us to take that data and turn it into a visual representation. So we took the data and used it to drive a 3D model of their operations. You could actually see the stockpiles and see the ships and see the railway and see everything, which they were very impressed with. But unfortunately, BHP Billiton, there's a huge company, and after we finished the title, they changed management and it never got taken any further. But that was something I did. And now, since then, I've been teaching at the Academy of Interactive Entertainment in Canberra for 10 years now. So now I teach game development. I teach programming. So that's what I do now. I really like teaching. It's really cool.
Because I think you said to me the other day that you actually end up now spending more time doing programming because you're teaching it than you were doing towards the end of your development career, right?
I didn't do any programming towards the end of my development career, but I do quite a lot of programming. But most of it is what I do is the students have assignments to do. So what I do when they're in between lectures, I'll open up Visual Studio and I work through the same tutorials that they're doing, so they can see me coding, and I code live while they're working through Zoom, ironically. And I work through the tutorials, but of course while I'm doing it, I talk to them, explain to them why I'm using particular coding mechanisms, why I'm using pure virtual functions, and why I'm using function pointers, and why I'm doing all this stuff. And I'll show them a bad way of doing it, and then I'll show them a better way of doing it, and then I'll show them sort of industry standard way of doing it. So I do a lot of programming, and also our course is very advanced because we're teaching people how to make games. So the latest thing we've added in is compute shaders. So I've been teaching them how to use compute shaders to optimize rendering, how to use multi-threading, and how to do all this sort of stuff. So it's really interesting because I get to experiment with this. I've done a lot of stuff in machine learning recently using TensorFlow, which is fascinating actually. It's really, really interesting stuff. Encourage people to have a go at that.
I mean, I can imagine probably the answer is maybe no, but do you ever use examples from the sort of Electron programming in any of the stuff? You do? Okay.
Yeah, I do, yeah. I do, yeah. I mean, I'll often show people how to, I mean, it's not so much the programming, because the programming is just too obscure for people, but sometimes I'll say, because one of the classic things I get asked from students is, why would I bother learning how to manipulate bits? Why would I care what a bit looks like? Because I mean, surely these days everything is integers and floats. So why do I need to know what's going on behind the hood? And I say, look, even today, compressing data is really important, because every time you load data, every time the CPU has to load data into the cache out of memory, it takes quite a long time, really, relatively a long time. It's much better if you can minimize the amount of data that you're moving around. It's still well worth doing. So bit shifting and combining of bits. And then I'll use some examples from driver and also from maybe also for the BBC data to demonstrate why bit shifting is so useful. Bit manipulation, ANDing and ORing and bit shifting, why it's so useful. Don't know whether they really care, but I do relate it back to that. I think it's interesting. Historically, it's interesting as well. They should know this stuff, because if you don't know where you've come from, you don't know where you're going to go. It's this whole thing about history.
Yeah, absolutely. And I mean, is there anything, like, looking back on it now, that you miss about the era when you were writing games for the Electron?
Oh, just about everything. Yeah, I loved it. I loved the whole only having 16 kilobytes and having to really think about how I was going to fit everything in there, and doing the art and doing the tools, and that really is a holistic iterative process of designing everything in one go. Change the tool, and then change the level design, and then change the actual game code, and then adding in another level, and then realizing I could do such and such. That was a really beautiful process, which I loved. And you just don't do that now. Because it's very somebody's designing the game, and somebody's doing the art, and somebody's doing the coding, and that's lost. It's just lost, really.
And I think, going back to what you were saying about how when you originally envisaged Camelot and Starport and possibly a third area being part of an overall story, if you like, do you have, in the games industry now, are there people who that's their role, is they come up with the story, if you like, for the game?
Yeah, absolutely. Yeah, that's what Ken Levine did in BioShock. He just wrote the story. He didn't do the level design. He just came up with this idea of a story of Rapture and Atlas and so forth, and he put that story together, and then he fed it to the designers and said, look, this is my story, and I want to have some sort of system whereby characters can develop their abilities, but then I want them to be able to swap those abilities in and out later on. That was his contribution. And then it was the designers went away and designed those systems, and then after they designed the systems, they came up with some basic level designs. And then once they had those basic level designs, then they hired level designers who actually produced all the different levels for it. And then they tell the artist what assets they wanted for the levels, and the artist would make those assets. So it sort of feeds down through the process till you actually get people actually making stuff, and then programs actually producing the code to drive that stuff. And there is still creativity in the games industry. You're not blind robots. Every single person does actually get to contribute something to it, and some organizations more so than others. I mean, Valve are they have a very flat hierarchy where even the people down at the bottom get to suggest things that they'd like to see in the game, and sometimes their ideas get to put in the game. I suspect companies like EA probably don't do that. If you're working on FIFA 2022, I think it's highly unlikely that you get to make any decisions at all as a programmer, because that's not the way EA works. But it's particularly if you work in the indie games industry, you get to make a lot of input.
Yeah. And actually, on that sort of, I guess, broadly indie game point, are you working on any games yourself? I know that
so I'm porting Starport into Unity 3D. So Unity 3D is sort of game engine that most people use for making indie games these days. There's two game engines. There's Unity and Unreal. There's a few others, but the others are pretty difficult to use. So and so I've been porting. I ported Quest. It kind of works. There's a version of Quest is up on my website if you want to link to it at some point. There's actually, and I've been working on a version of Starport as well, and I've quite enjoyed it. It's been really interesting actually to take these games and make them work on Unity. It's been a really interesting experience. I don't expect to make any money out of them, but it's been really interesting from that point of view to do it. We were going to replace the graphics with modern graphics and a modern animation system, but the guy who was interested in doing that decided he doesn't want to do that now. So I'm probably just going to release it as using the original graphics and original layout. It's quite interesting to do that. And there may be some interest in it. I think it's, the games still play pretty well, actually. I was playing Quest the other day. It plays pretty well, actually, for an old game. It's quite fun I thought it was fun to play anyway. Yeah.
And do you have any of your old hardware still from
Unfortunately, I don't know, because I've moved around so much. I came to Australia. I kept quite a lot of it in the attic, and it moved around with me. And then when I came to Australia, I rented the house out that I was living in. And it wasn't until about 4 or 5 years later that the house was sold. And I relied on somebody to clean the house out. And they gave me instructions to keep stuff that was in the attic, and he didn't. He just sold it on. And I was just living in Australia at the time, and I had a lot of other things going. I think I was in the middle of working on Child's Ventures, so I was crunching on that. I just didn't have time to worry about what had happened to my old Electron. So unfortunately, I lost it. But yeah, and all the old source material for Quest and Starport and Camelot, which I'd kept up to that point.
Yeah,
I don't know where it went.
Fair enough. I mean, I can understand if you move to the other side of the world that some of this stuff would unfortunately.
It's just the nature of moving, unfortunately. Yeah.
And are you pretty much settled now in Australia, Tony? Are you ever likely to come back to the UK, do you think?
No. I really like Australia.
Yeah.
There's things, there's pros and gets to everywhere, but Australia is a great place to live. I mean, there's, you've got a third of the number of people not in the UK living in a country which is 20 times as big. So, there's a lot to like about it. I mean, the middle of the country is almost entirely desert, so you can't live there, but there's still enough around the edges for it to make it really, really beautiful. You've got thousands of kilometers of beautiful beaches and beautiful mountains, and the weather's a lot kinder here, and it is much. I don't know. I wouldn't go back to the UK now. I lived in the northeast in Newcastle upon Tyne for a couple of years before we came out, and I bought a Gore-Tex jacket because it rained every single day. It just rained. When I was working on Driver, this was. I mean, not that I ever got to go outside when I was working on Driver, because we were working like 80 hours a week. I'd literally get in my car at the end of the day and go back to bed, and the next day go back to work. But when I did get to go outside, it was always raining. But in Australia, it doesn't rain very often.
Yeah.
We literally can say, 2 weeks time, we're going to have a barbecue outside in the park. You pretty much know that it's going to be sunny. It would be amazing if it wasn't sunny. So it's great. I love it here. It's great, and and we don't have any COVID-19 here.
Well, yeah, that's another bonus. Hey,
we do have a little bit actually. We had a few hundred cases. I think we've had 1,000 cases or something since the epic since it began. But it's tiny. It's really, and people here complain saying, "Oh yeah, I couldn't go to a cafe for a week." Yeah, you live in the UK, man. They've not been to a cafe for a year.
A month, months,
not allowed out of the house.
Yeah. Well, first of all, thanks very much for all of the content that you've just covered, Tony. We've got a few questions from the group. If you're all right taking those.
Sure. Yeah.
So first question, it kind of touches on, I think, something I asked you just now in regards to some of the original materials. So I appreciate you don't have any of the hardware. What about any of the source code or anything like that? Do you still have any of that?
It's all gone. It's all gone.
Yeah.
Unfortunately, it was all stored on 3.5-inch discs, and it's all gone. My parents did have some for a while, but they gave it me back, and unfortunately, it all got lost, so I don't have it. Yeah. I have got the original. I've got some of the original games on tape, which I got from, because Superior, as part of the deal, they give you some copies of the game. So I've got an original copy of Quest, and an original copy of Starport, and an original copy of, but they're available on eBay anyway, because you can buy them. Yeah, but I don't have the source code, unfortunately, no.
Yeah, we've got somebody else in the group. Chris has said that he says he remembers he enjoyed playing Quest. Didn't manage to finish it, but he's still got the original disc. So there's
Cool,
still people with the original discs out there.
Yeah, that's really cool. Yeah, great. And it's nice to know that people still play it, and it's really cool to. Sometimes I do a Google my own games, and it's really nice to see people reviewing it on YouTube and stuff, and talking about these games. It's nice to know that people enjoyed something that I created, and even now, I talk to people and say, oh yeah, I remember you did that. That was really cool. It really influenced the direction I took. And so it's cool, I likewise, I was really influenced by Citadel and the games that I played. We all stand on each other's shoulders, I guess, and that's what we do.
We had a comment from Tricky, who said that the tools that you had on the screen, those editors that you used for Quest, they look a lot more advanced than perhaps other editors at the time would have been for games development. You must have put quite a lot of time into those.
Yeah, but I one of the things I realized was it definitely worth putting effort into your tools. And that was another thing that I think was to my credit, and we do put an emphasis on that now in game development, because the better the tools are, the more efficient your processes, and it makes it a lot easier to make games. And when they weren't, I didn't have a mouse. I got a mouse after Quest shipped, actually, because there was I can't remember what it was now, but it was actually, ironically, it was called the Quest mouse, wasn't it? I think it was called the Quest mouse. It was a mouse which plugged into the serial port on the BBC, I think, or something, which allowed you to actually move the cursor back with a mouse. And it was a revelation to me when I saw a mouse for the first time on the BBC. And it came with this really simple art package, and from then on, I used that for all my editing. But when I did Quest, I was using the cursor keys to move the pixel, to select the pixel, and then I pressed the return key too. Oh no, I think I used W8. I think I used the same keys that they use for controlling the game: X, Y to move the cursor left and right, and colon and whatever dash to move it up and down. So it was all keyboard driven because I didn't have a mouse. But yeah, I did put quite a lot of effort into them, and I remember putting quite a lot of effort into the feedback, so I'd know what I was doing. Because as I was using the tools, of course, I'd wasted a lot of time because I was using the tools, and then I realized the tool didn't do what I needed it to do, or I kept making some stupid mistakes because the tool wasn't giving me the necessary feedback. So then I'd edit the tool to provide that feedback. But it was, the tools were very much designed for my own use.
Yeah.
So yeah, I did put quite a lot of effort into it. It definitely paid off because, yeah.
Question from Dean. So do you have any suggestions on how to do game level progression? So Dean says he's been writing a mobile game in Unity 3D, but he's kind of stuck trying to increase the complexity or introduce a reward mechanism.
That's kind of a very general question. I mean, it really is contextual of the type of game, really. Could you be more specific? I mean, I don't mean. I mean, there's lots of mechanisms you can do. I mean, the main one is you provide people with some sort of way of increasing their stats or something like that, or I guess I don't really know how to answer that.
He says it's a touch-based game for a mobile, as in terms of what it's like. He says he's tried like increasing speed and things like that.
Oh, okay, yeah. Yeah, I mean, I suppose what I used to do in my games, if I was doing a platform game, for example, I'd have a number of basic enemy types. So you've got an enemy that moves left and right, an enemy that moves up and down, an enemy that moves diagonally around the screen. And I'd always start by introducing them one at a time. So you introduce, just the left and right moving enemies, and you maybe have a few different variants on that until the player gets used to it. Then you introduce the vertically moving enemies. Then you introduce the diagonal one, and then you start mixing and matching. You might have one vertical and one horizontal. So there's all this. So you can actually reuse your stuff quite a lot of times before the player starts to get bored with it. So yeah, that's the sort of thing I would do. And providing with power-ups and stuff. I think Mario does this very, very well. They introduce, they gradually introduce all these different abilities. Another game that does that really well is Metroid. All the Metroidvania actually games do that.
Mm.
They're a really good source of reference for how to actually, keep the player interested and provide that learning curve.
Yeah.
It's a real skill. Making games designing games is a really hard. Getting that learning curve right is one of the hardest things to do, actually.
Mm.
Yeah.
And Dean's also just added that he says he spent quite a lot of time testing it, and that might be making him think it's less challenging than it is. Like you had with Cyborg Warriors.
Yeah, that's absolutely right. I mean, actually, that is a really important point. This is something that we stress to our students: is you really can't. The best way to get a good game is to get independent testers to test it on a regular basis. You really do need to get somebody in who's never seen the game before and sit them down in front of it and get them to play it. And you've really got to resist the temptation to tell them what to do. You've got to sort of sit back as a third-party observer. And big studios, what they do, they have two-way mirrors, and they get the computers in, and they get the developers in one room, and they get testers in, and people who've never seen the game before, they just sit them down in front of the game and they have to play it. And the designers aren't allowed to interact with them in any way.
But they can see them.
They can see
amazing.
them,
Yeah.
And they video it as well. And afterwards, they analyze the video. And a lot of them, they use things like eye tracking now to see where they're actually looking on the screen and stuff. It's very technical. But really, getting people to play your game is really the only way to get a good game. You will never make a good game if you're just playing it on your own, because you will never be able to, get the learning curve right or solve those difficult problems. So you've got to really,
He says thanks. He'll try and get some testers.
Yeah, get some testers. Get your family and friends to test it first.
Yeah.
But, if you're doing Unity 3D, you can release the game on the forums and get people to play it, and people will give you feedback. And then you just need to actually incorporate that feedback.
It's not a question, but just a comment from somebody in our group, Bill. He says that he created the Quest, the Camelot, and the Starport maps.
Oh, cool! Brilliant, thank you.
He's a big fan of the games.
Oh, that's
how they
really
played.
cool. They're really good maps. I know he did the same thing for Citadel as well, and it's a really good map. That was great. Yeah, okay. How did he do it, by the way? Can I see the chat where?
Hang on. If I ask him if he's able to, let me see if I can get him to unmute. If it will let me. I'm not sure if I can take him off mute.
It's okay. But yeah.
Oh, he says he did it with screen captures in BBEM. That's what he says.
Oh, okay. Yeah. All right, yeah. There's quite a lot of work there to do that, because really good. So you played the game and then screen grabbed it.
Yeah, it's pretty cool.
That's cool, yeah.
He says he had to cheat in Quest in order to get the screen grabs for some of it.
Yeah, it's fine. Yeah, of course, I would have had to cheat as well.
Yeah. We have got someone in the group who I'm quite keen, if they are able to enable video, to ask you some questions. So this is 0x Code, who is writing games for specifically for the Electron now.
Cool.
I think he's quite keen to ask some questions. Let me see if I can ask his.
It's been a long time since I've programmed any Electron code. Been about 30 years.
You should be on now.
Yeah.
Yep.
Hello.
Hello, Tony.
Hello.
Thanks for a very great talk.
That's okay.
I'm really inspired by your games on the Electron specifically, and
sure.
I'm trying to make some games on the Electron. I'm only 35 years late to the party, I think. But there's so many things that you're talking about that resonate with me, like limited memory, limited speed, all kinds of things that you would have on the BBC, but you don't have on the Electron. And I'm basically an Electron fanboy myself. And also what you just said about having testers, because I remember creating my first game. I'll be talking about it after the lunch break. It was too hard. It's still hard, but I could only play it myself, and nobody else could play it. So it's rubbish if nobody can play your game, right?
Yeah, absolutely, yeah.
And now I've managed to get my 2 teenage children to play test for me. And you said, I just observe them. I don't give them instructions. I don't give them hints. Just see, okay, do you understand the game? Can you progress in the game? And that's a really good way to do it. So I've been looking at your games, even in, especially in technical terms. It helped me to tune my own Acorn Electron emulator. It helped me to understand the tricks that you use, like switching to mode 6 during phasing for speed, stuff like that. But I'm wondering what I get stuck with, or at least limits my fantasy imagination. I've got 128 rooms in my current game, and that's mode 5. So you've got twice more memory, at least less memory for screen, right? You have 20K in mode 1, 10K in mode 5.
Yep.
So I'm just wondering, how did you manage to get so many detailed screens, mode 1 screens, into Starport, into Quest, into Camelot?
Okay, so I used a really intensive tile-based system. So if you look on Quest, you can see the back of my screen here, actually. I can't show you. But the screen is actually a 5x3 grid of tiles, and they're quite a coarse, it's quite a coarse square. But then each of those tiles is actually made out of separate characters. So the bricks are, a repeated set of bits, basically. So that tile is made up out of 8x8 subtiles.
Yeah.
And each tile is coded as a vertical line of characters in Quest. So it's a really complicated series of encoding which you use. And then what I do, I flip the same tile. So I think it's 32 tiles, but I have a bit which allows me to flip them across left to right and upside down. So I can flip that pattern around 4 different ways. And also I can change the actual, the fill tile as well. So you basically what you're doing is you're taking a very, I guess it's just a very compressed way of storing the data. Yeah. So and it's very proprietary as well. So you're quite limited to what it works well in some environments. It's very bad for doing organic things. So trying to make sort of organic cave looking systems, it doesn't do very well at all.
Yeah.
Geometry, it looks quite good. It gives quite nice edges and shapes. It looks really good for bricks and stuff.
Yeah.
But trying to do things more organic, it's very difficult to do. But there's different ways of doing it. If you talk to, did you look at the book, Acorn World in Pixels? Have you?
I've got the book, but I didn't read all of it yet. So.
Okay, so you should read the section by the guy who did Citadel. What's his name? Jacobson.
Michael Jacobson.
Michael Jacobson. Yeah, he did a completely different system. I had no idea how Citadel worked until I read the book, and I was amazed. What he does, he fills the entire screen with a tiling background graphic, like bricks or rock or something, and then he draws black triangles over it to cut the passages out.
Yeah.
So he just so that way he can have really nice diagonal shaped passages and passages of any shape. And of course you can press that data down enormously, because all you're storing for each triangle is he probably only stores, he doesn't need to store full accuracy. He probably stores, I don't know, probably get away with like 4 bits per the X, 4 bits for the Y. So so he can press that data down a lot. So that's the sort of technique we used to do. But tiled backgrounds is probably certainly how I did my stuff, and I'm pretty sure that was how things like Codename Droid were done as well.
Yeah,
they probably also were tiled. So Exile used a completely different system. Exile used some sort of weird procedurally generated tunnel system.
Yeah.
They used quite a nice mathematical formula to generate their system. It's kind of similar. Have you ever seen a game called No Man's Sky? You heard of a big game called No Man's Sky, which is an open world?
Yeah, I've heard about it.
Yeah, so open world. That's kind of the logical development of Exile. Exile is the same sort of system, but No Man's Sky is doing it in 3D using much more complicated maths algorithms. So does that answer your question?
I'm still amazed because I'm using a tile-based system. The tiles are pretty big.
Yeah.
I'm even thinking about meta tiles, so tiles made of tiles. And I'm still struggling. I'm using heavy data compression. I'm still struggling to get the 128 rooms in the game, but that's probably my limited knowledge. Yeah.
I think Citadel had 200, didn't it? Citadel had a lot of rooms, but imagine it's mode 5, isn't it? Citadel is mode 5.
Citadel's mode 2, actually. Yeah.
Oh, it's mode 2. Oh, it's mode 2. That's right. Yeah, it is. Yeah, it is. That's yeah.
And I've got one other question. Thank you. So, how about designing sound effects, music?
Oh, okay. Yeah. So I didn't really have much. opportunities to really do much. On the Electron, it's very primitive as to what you can do. It's just beats
Yeah.
really the Electron.
Yeah.
So I didn't have any tools for it. I just basically, some of it I did using, I have some very simple data stuff. So I have a string of numerical values which I could feed to the sound chip, and I just edited that by hand until I thought some sound effects that I quite liked. And some of it's actually just random. I just generate random noises and just feed it to the sound chip to sort of get that sort of blah, 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 noise and so on, which is not particularly exciting. But yeah, so the sound design is probably the worst bit of Quest. I think I didn't really put a lot of effort into the sound design.
Yeah.
So yeah, sorry about that.
But still very impressive. Thank you for making these great games and talking about it.
Pleasure. Yeah, it's absolute pleasure. It's lovely to talk about it. Actually, it's great. Yeah, I'm glad you're carrying on the tradition and making more games.
Yeah,
it's really cool that you guys are doing that.
Yeah, sure.
Okay.
Yeah, cool. Just to highlight again, I think you mentioned it just now, but Zero X Code is going to be doing a talk at 1:30 this afternoon, specifically about his games development. So just as you were the Electron coding wizard in the 80s, Tony, he's taking on your mantle for the 2020s.
Yeah, it's good to know somebody's still doing it.
So just in closing, Tony, obviously we want to say thank you again for making the time to do the talk and answer questions.
Pleasure.
I'd like to give the last sort of comment to Jim, actually, who's just sent this while we were talking. He said that one of the reasons that he actually took up programming on the Beeb was because of the programming articles that you submitted to Electron User in 1988. And I think for a lot of us in the group, like the games that you produced were a big inspiration for a lot of us. So thank you very much. And,
it's a pleasure.
It's been really great to talk to you. What we like to do with guest speakers, it's probably feels a little bit artificial because it's a virtual environment, but if I could ask people who are in the group, if you could come off mute and put your camera on, just so we can do a round of applause for Tony.
Yay!
Tony.
Well done.
So nice. Thank you so much.
Thank you, Tony. Thank you.
Thank you. All right. Okay. Thank you very much, guys. I'm going to go to bed now. It's
just
my bedtime.
Quite late for you.
It's gone 11 o'clock at night. I've been up all day. Pitch back here. All right. Have a great day. I'll speak to you guys.
Thank you very much, Tony.
Bye.
Bye-bye.
Bye.
Bye.